So let's see. So first thing, hello.
Hi.
So first stuff that we had from chapter 13 was talking about a wave. We had couple qualities. We had the height of the wave, which is the amplitude, wavelength, lambda, and then we had T, called the period, and the period is the amount of time to travel one wavelength. And frequency, which was 1 over time. So this is how often a wave repeated itself. And if we put all these things together, we get the hold on, let me just fix that. So put all these things together. We got the velocity of a wave is the wavelength times the frequency. Okay. So with this, we led into electromagnetic waves. And a couple basic qualities. This was all in chapter 21. So the speed of light in a vacuum is 3 times 10 to the 8th meters per second, and it is constant. So the only way light speeds up or slows down is if it goes into something. And this is related to electricity in magnetism because of our two constants, epsilon naught times mu naught equals 1 over c squared. So this is how we derived the speed of light. And we also found that given how these constants work, light is two fields. It's a magnetic field and an electric field kind of alternating back and forth together. And we found that the strength of the electric field divided by the strength of the magnetic field is the speed of light. So this was another interesting tidbit. Okay. I think this was everything we had from 21, and then we went into 22. And math-wise, 22 was pretty straightforward. Like I said, not a whole lot of equations on this test. So we had C equals lambda F. The energy equals H times F, where H is Planck's constant. Which is 6.6 times 10 to the negative 34 joule seconds. And we got to the bulk of our section here. So reflection and refraction. And it's all about light coming in to an interface. Light comes in at some angle, and it can do one of two things. It can either reflect, which means bounce off, or it can refract and come over this way. And how this happens is governed by these two equations. So I'll do them in different colors. So in reflection, we have theta incident equals theta final. And in refraction, we have N1 equals N2 sine theta 2. And this is based on the fact that as a ray of light goes between two materials, it will travel slower in some materials than others. So the N value is how fast light travels in that material. So where's good section? So the N value is defined to be the speed of light divided by the speed of light in that material. And generally, N value is bigger than 1. Yeah. So, and for the most part, everything that we did kind of comes out of applying these things in different situations. So does anybody have any questions or anything that they would like to go over and discuss? Well, that's the long and short of it. I don't know if you guys got any questions.